Got to give the people what they want. All right, it's Bass. I'm making this video on Saturday. We're going to make it quick. I'm going to make this happen for you guys. Let's get it. Rationalizing the denominator. What the heck is that? So, basically, you never want radicals in the denominator of a fraction. This right here, you don't want it. Niggity, niggity, niggity. No, don't want that right there. So, what we would do, we're going to use some basic algebra to rationalize or get rid of the radical that is in the denominator, okay? So look at this example. 3 root 3 over the square root of 7. Basically, what we're going to do is we're going to multiply it by something else that equals to 1. And remember, anything over itself is equal to 1. So root 7 over root 7 is just equal to 1. So by multiplying by 1, just like with fractions, I'm not actually changing the fraction, right? 3 over 3 equals 1. Root 9 over root 9, which equals 3 over 3, is still 1. So root 7 over root 7 is 1. So I'm really just going to take the initial thing and multiply it by 1. But something really important happens. Where's my eraser? Something really important happens when I multiply root 7 by root 7. And that's what we're going to explore right now. So think about this part. Root 9 times root 9. Well, what does that equal? Well, let's think about it. What's the square root of 9? 3. What's the square root of 9? 3. What's 3 times 3? 9. So root 9 times root 9 actually just equals 9. I wonder if that works all the time. Look at this one. Root 25 times root 25. Well, what's the square root of 25? 5. What's the square root of 25? 5. What's 5 times 5? 25. So see what happens here. When I take this and I multiply root 7 by root 7, it just ends up being 7. And then I end up with, what is this? 3 root 21. And I have just rationalized the denominators. Root 7 times root 7 is 7. Root 3 times root 7 is the root 21. And then 3 is still a 3. So let's see how this looks in the real world. Why don't you try to rationalize this denominator? What do you think you're going to do? Go ahead and try to do that right now real quick. Hopefully you said, I need to take this whole thing and multiply it by 1. But instead of calling it 1, I'm going to call it root 9 over root 9. Well, what do I get? Root 9 times root 9 is 9. And 12 root 5 times root 9 is 12 times root 45. Now I need to see, can I simplify just root 45? I wonder, what goes into 40? Oh, 9 definitely goes into that. So 45, I could call, what is that, 9 times 5? 45 is 9 times 5, which is root 9 times root 5. And we already know that there is a root 9 in there because we multiplied it. So that's 3 root 5, right? So this is now 12 times 45 became 3 root 5 over 9, which finally became 36 root 5 over 9. And now I need to see, can I simplify 36 and 9? Yes, I can. I can divide, divide them both by 9. Divide by 9, divide by 9. And I end up with 36 divided by 9 is 4, right? Yeah. 4 root 5 over 1. Look how that worked. Bang, 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 bang. We're just going to do maybe a couple more examples. Do this next one on your own right now. 10 times 3 root 10 over 3 times root 2. What do you think you're going to multiply it by? I'm going to use root 2 over root 2. So I end up with 3 times, well, what was root 2 times root 2? 2 over 10 times root 2. This gives me 6 over 10 root 2. Easy peasy pumpkin squeezy, just like Ari says. All right, next level stuff. What am I going to do here? I got to rationalize this denominator, get rid of root 14. Okay, root 14 over root 14. This is going to be a 14. Now I have And this is what I'm thinking. I have root 2 minus root 3 times root 14. I have to distribute. This is that distributive property. So what I end up with, root 14 times root 2 is root 28 minus root 14 times root 3. I don't know, 14 times 3, 12, carry the 1, 3, 42 over root 42. I can't subtract those like that, but I can leave them there. Now, wonder if anything goes, I can rationalize the top and the bottom. I'm actually going to move this down so I get some more space. We might not even do this one in this video because this is actually getting more than I even needed you to do. All right. So let's see. Can I rationalize? What can I do with root 28? Root 28 is 4 times 7, which is root 4 times root 7. Terrible looking. Which is 2 root 7. That's what 28 is. Root 42. What numbers go into 42? 4 goes into... Does 4 go into 42? 36. No, 4 does not. 3 times 3 is 9, does not. 4 times 4 is 16. I think 42 might be it, if 4 doesn't go into it. 16 times 2 is 32. Nope, that's not going to work. 4, 5. Yeah, I think 42 stays the same. I don't think we can simplify root 42. So we end up with root 28 turned into 2 root 7 minus root 42 over 14. Boom, boom, boom. That's it. That's all I want you to see before class. We'll work on this in class, and we'll get it going. All right, short video. Thanks, you all. Have a great rest of your weekend.